Well, greetings once again, VAC fans, and I find myself in Florida at my parents' abode with their Miele. It's a Miele Callisto, and it's an SEB228 power nozzle, and it probably hasn't been serviced in about a year, so that's why it looks like that, although that probably isn't too bad for being a year old. And I've got a few little doodads down here. Let's see. I got a medium-sized cardboard box. I have this compass. I have something I can measure with, and I've got some packing tape. I managed to bring all my test instruments with me on the airplane, but I wasn't going to bring my airflow box. So let's go ahead and make one. So a couple of helpful hints in making an airflow box is you want to try to capture as much of the nozzle airflow as you can. It doesn't have to be super accurate and precise, but you definitely don't want your largest nozzle to be smaller than the opening on your box. If it is, and sometimes it is even for me because I measure all different kinds of nozzles with my box, you're going to have to block off the excess gaps, so to speak. So this one right here, see, I almost got my handy-dandy tape measure kind of caught, is about, I'm going to say it's about 12 inches. It's a little bit more than that. It's about 12 inches in length, and it's a little bit more than an inch and a half or so. I mean, it's almost 2 inches, but not quite. So I'm going to pick, for the main opening that's going to be on the top of the airflow box, I'm going to pick probably 12 inches by about an inch and a half. And the main thing is you want to make sure that the bristles, when spinning, because I do airflow tests with these spinning, I don't want them to be hitting the cardboard at all. So I'm going to go ahead and I think 12 by an inch and a half will be pretty good. But you need to have your measurement opening, and that needs to be set to exactly 2 inches. Why 2 inches? Because, well, it's really windy out here, because that's the standard of measurement that we chose a long time ago. That is 1 inch in diameter, or 1 inch in radius, 2 inches in diameter. So I'm going to go ahead and set this. It's so windy out here, some of the stuff might actually kind of blow around, but I need to set this to 1 inch, and then I need to make a 2-inch hole for a my measurement port where I'm going to put my anemometer. Alright, using some fairly thick packing tape, we have the bottom, or maybe it'll end up being the top, won't really matter, sealed up pretty well. So just as long as your packing tape is fairly thick and doesn't come off and it's pretty sticky, that will actually be good enough. You can put more tape on it if you want to. Make sure that you get all the edges. And this right here, this is real thick cardboard on both sides. This isn't going to leak air. But remember, this is going to be an airflow box, not a suction box. Alright, so now we have made an empty sealed box. And if you look closely, I went ahead and got some of the edges that I felt needed a little extra taping. Otherwise, we have a 16 by 16 by 15 box. Now you could cut this down and make it not as tall, but I'm just kind of doing this quickly. It'll probably be best to actually make it not quite as tall because you don't really need height. But there's a tape job. It's nothing fancy. You just need to make sure that you get all the edges that could possibly leak. Maybe even 2 pieces of tape. And this won't leak. It will give you very accurate results. So now I have to cut 2 holes in this. One is going to be rectangular for the nozzle, and then 90 degrees from it, I'll go ahead and make a circular 2-inch in diameter hole, and that's for the anemometer. Alright, I now have a 12-inch wide by 1.5 inch deep rectangular hole I need to cut out. And then here is a 2-inch diameter, 1-inch radius hole that I'm going to go ahead and cut out. Alright, I finished the cutting. And you know what? If you happen to make a mistake or whatnot, just put a piece of tape over it. You'll be okay. So there is the opening. That's where we'll put the power nozzle, or any other nozzle you want. There we go. And I can clean that up with some tape. And here's the 2-inch. And there you go. So we're pretty much ready to go. Alright, we're now done with all the taping and all the tweaking of the box, unless something somehow falls apart. You can see I've got some tape here, reinforcement tape here, and some stuff on the sides because there's going to be an awful lot of weight and a lot of stress in here, and I want to make sure that not only do we have a good seal, but nothing actually collapses. And I've rounded out the rough cut hole so it looks much more round. I don't think it's perfect, but it's pretty close. There we go. It's a good focus on that. So this is like a $1.20 some odd something box here from Walmart, and it's ready to go for airflow testing on a Miele Callisto S5281, if I'm remembering the number right. It's very windy out here. See all the plants? Well, after what seemed like 20 minutes, I got that string, that thread, completely out of the brush roll. And hopefully I didn't actually scratch anything. And I have all my most important test tools here. Brought them with me on the airplane. So we're going to have lots and lots of tests with this particular Miele, not just necessarily an airflow box test. Now you can see how much crud is on the side of this brush roll, both sides of the brush roll. I had to do this last year as well. So you hit a lot of baseboards and whatnot, and that's just kind of what you get. And this is what I have to clean it. Might not be the best thing, but typically I use that and it's some pretty good results. Although I suppose if you really go nuts with it, it can certainly dry out the plastic. Alright, some of the things that I wanted to do was figure out how much power this thing actually uses. So we have this, I guess, power adjustment button, so to speak. Starts at minimum, and I assume that that's 300 watts. And then you can go and turn it all the way up here, and that would be up to 1200 watts. So let's see how accurate that is. Also, I wanted to show everybody that when you increase the power usage on a machine that's plugged into a standard 15 amp circuit, that you will have the voltage actually drop. So at home, I have a dedicated 20 amp circuit that I use, and the voltage actually doesn't drop when I go and hook up even higher powered machines than this to it. So let's actually see what we have, and I'll run through all the speed ranges here. So we're starting at 119. I'll turn it on here at 300 watts. See the voltage drop? Okay, now here's the next level. Here's the next one. Here's the next one. Next. And there's all the way up. So 117. That's all the way up. Alright, now let's take a look at power usage. It's about 10 amps. And that's the peak power usage. There we go. That's the current power usage. Now I'm going to turn the speed down. And now here we are on low. And this machine is from 2012. And listening to that motor, sounds like we got some dry bearings. Incidentally, I took all the filters out, and I want to do a straight fan test. That is, straight in to straight out, no interruptions with any filters whatsoever, just to see what this thing can actually do. We're going to test all 6 speeds. I'm going to start out with the lowest one first. Let's see what it does. See, we started out, we're at about 119 volts right now. All right, I think we got a peak here of 2874. Let's see, 2874 times conversion factor. And that's 75 CFM. So 75 CFM on low, lowest one. Now up here. Let's see what our next peak speed is. Looks like we're still gaining a little bit. Alright, that looks like we've peaked out. 3366. Alright, about 88 CFM rounded. At the upholstery speed, I suppose. Let's go up to diamond carpet, low pile carpet, I imagine. I think we peaked out. All right, that's about 104.3. Let's go up higher. All right, that's about 115 CFM. Right there. Let's see, the voltage is dropping a bit. Second from the highest. Oh, no, it bumped up a little bit. Okay, 4862. Do it again. All right, about 127 CFM. Now, time to go all the way up. We're at almost 117 volts. Well, 138. No filters. All right, so just as a reminder, this machine's from 2012. To me, it sounds like probably time for new motor / new bearings. Really, just probably needs bearing repack. But light and or ungreased bearings usually run a little faster than fully greased bearings. So 134, and that is about as sealed as I can get. Now, I have seen, like for an S3 and whatnot, that this has a motor rating of 140, maybe 141, something of that nature. But remember, my voltage isn't maxed out, and that will definitely add a few CFM. So I could believe that maybe a perfectly good working machine with 122, 123, maybe 124 volts might hit 140 some odd CFM. So that is certainly within range. And as a reminder for the bazillionth time, this is a straight airflow test. So that's great from such a nice small compact canister. And this only is maxing out. You know, it says 1200 watts. We were testing it was around 1100 watts. So pretty good. More tests to come. A lot more tests to come with this guy. Always wanted to do a particle counter test on a Miele. We have actually a new bag, new filters. The HEPA filter is a year old though. So let's see what it does with a year-old filter. I don't happen to have any new ones available. Not just yet. That went down a bit. Maybe I got a better seal. I can run it again. Anyway, it's very low to be sure. There we go. Got a 0. We got a 0. This should be another 0. We got another 0. Stay focused. We got another 0. Got 3 zeros. And we got 4, alright, yeah, 0. We got it. Alright, so if you want a machine that literally blows 0 particles, all 3 channels, this is what you get. And this is even from a HEPA filter that is fully 1 year old. Alright, I've got a clean bag. But it's still the same year-old dirty HEPA filter. I don't know if that's going to make a whole lot of difference. And I've got a fresh, clean GN bag. Not this one. This is the one that's, I don't know actually how old that is, but it's dirty. So I got a brand new, fresh one in there. So let's do the same set of tests with all the filters in. We're starting out at 116.5 volts, and that's going to go down. All right, here we go. How much airflow will the bag use? All right, so we got 2165. So we're at 56.5 on low. All right, so 2716. Now we're at about 71. Upholstery setting. Got a little more out of it. It's going up. All right, 3327. All right, it's going up more. I'll give it one more chance. All right, 3366. No, 3366. Well, I'm not hitting that time, but there we go. Yeah, that's it. So about 88 CFM. Oh, and it just went up again. All right, well, you get the idea. You can kind of figure that out. All right. To me, this looks like ear for cleaning ears, apparently. Let's see what that is. 3760. All right, I'm going to take it at that, whether it goes up or not. All right, 98.1. See, our voltage is dropping a bit. Not much, but some. All right. Second to the highest. All right, I'm going to do 4094, whether it goes up or not. Oh, it just did. It just went up. Whoops. All right, I'll do it again. 4114. All right, 107.4, and I realize it just went up again a little bit. So, a little over 107. All right, now let's go all the way. Let's see what our voltage has gone down to. See, it's dropped a little bit. That's 115.1. Okay, we're getting our final. That's using a clean bag, but a dirty HEPA filter. All right, 4468. 117, we'll call it. All right, so the main suction unit with clean HEPA bag and that other little kind of squarish filter in there, the one that's like this thin, but a dirty HEPA filter, we're maxing out at 116.6. So what I'm going to do now is I'm going to take the dirty HEPA filter out, and I'm going to see if that airflow rises a little bit. And if it's, like 1 or maybe 2 CFM, so what? It's really much of a, it's just kind of useless to go ahead and to change it. Too much of a bother. But I already did earlier test the particle count, and it was a perfect 0. So even if it's a little discolored, it might still be working just fine. So I'm going to take the HEPA filter out, and we're going to do an airflow test and see how close it comes to 116.6. All right, the dirty HEPA filter. That doesn't look that bad, but it certainly is stained. Remember, this tested a 0. Let's see how much airflow that actually robs. And we're at full speed. Well, a little bit, isn't it? Okay, so we were at 116.6. We're now at 125.4 minus 116.6. So that filter No. 125.4 minus 116.6. There we go. 8.8. Now the thing is, I don't have a new one of these to see actually how much a fresh clean one does. It might be that a clean one sucks down 6 CFM, maybe even 8 CFM. In my experience, depending on how large these are and how well they're designed, they could usually say suck down a couple of CFM, but this one right here in its current state is 8.8 CFM, but that one has definitely got some stuff in it. But I don't know if that's normal or not, so we'll have to get some fresh ones. By the way, I do have a 2-pack of those on order from eBay. So if I get it in time before I fly back up to Ohio, then we'll test them out. All right, time for some suction tests. I have removed any and all filters, so this thing is running naked, as it were. And I can see we're at about 118 volts at the moment. So let's see what this thing can do. Will it break 90 inches of water lift? And we're set on high. All right, so I'm going to give it maybe 92 inches of water lift or so. So, I mean, that's great. And it may actually have gone higher than that. This is the best seal that I could actually make. So, had this in here for some additional sealing material. And then this, of course, fits right down in there. And that's the highest number I've ever seen, is just touching the 90 mark. So I think that's pretty good. All right, I did an initial run on the airflow box. I didn't have that good of luck, but I'll tell you actually what I did. So I went and used some of this masking tape. Was able to get a good seal all the way around the front and all the way around the sides, even over to here on both sides. But this is proving to be problematic right here. This lifts up, doesn't make a great seal with the box. So I'm going to have to figure out a way how to go and block this general area off, this whole area back here, so I can try to isolate just this opening is better than I currently have. So I ended up with just 40 CFM. I know that's not right because I've seen, I think Blackheart's tests come out with a lot more than that. So I've got to figure out a way to seal this up. So I'll be back when I can figure that out. All right, round number 2. This is a hand towel, and that's some more tape. So let's see if I'm able to kind of seal off the rear of that nozzle and get a better reading. Certainly better than 40 CFM. I know it'll do more than that. I had a question on whether or not a 1-year-old HEPA filter, that this one still blows a 0, it's 1 year old, would be any different in CFM loss, or particle count I suppose, from this brand new one that I just got. And I think this one might be slightly different than the one I currently have in there. It appears to have this little charcoal pad in here or something like that. So this is brand new. This is the one that's just currently in there. It's been in there for a solid year. So let's take a look at the airflow. Already measured the particulate count, and it does blow a 0. All right, you hear that whine down? So we definitely have dry bearings. And did you hear the anemometer whine actually change speed? So looks like we got some speed variance in there. I don't know if that means the carbon brushes have issues or what. So that's why I traded it for a Shark NV355 that I got my parents a couple days ago. All right, so 4528 times conversion factor. And we're at 118.2. And now let's see if I can do this without the anemometer falling off. I have it taped fairly well, but you never know. All right, so let's take the 1-year-old filter out. See that, right? Let's go ahead and put the brand new filter in. It's seated well. Okay, anemometer, stay on, stay on. All right, I think we're in pretty good shape. Let's go ahead and run it again, see what we got. And this is just a difference test, not an absolute value test. Alright, so I don't think there's really any appreciable difference. So 118, 119. The other one I think I've probably forgotten. I think it was like 118 something as well. So no appreciable difference. So that's between a brand new 1-year-old one and, well, sorry, well, when it was new, I guess a year ago. 1-year-old compared to one I just put in just now that I got in the got a 2-pack there. And by the way, I found these on eBay. It was 2 of them for $16 shipped. So, and I'm sure that this will probably also blow a 0 as well. So you can use these filters for quite some time, even though they look like that. Here's a close-up of the other side. I mean, there's a definite difference between the two. However, this looks just fine to me. I'm not really seeing a whole lot that I have to worry about. Obviously, this is darker than that one. Of course, on the other side, I can't really, they're side by side. I can't really compare one way or another. But yeah, they're fine. So not a big deal. So it's your choice. Depends on obviously the environment you use it in. But the bottom line is there's no appreciable difference under standard usage in 1 year for one of these Miele filters. And now for the piece de resistance. So we have a clean HEPA bag. We have a clean pre-motor filter, never been used to vacuum any dirt whatsoever. But we do have the 1-year-old HEPA filter in there that we figured out makes like a half a CFM difference from here. So no appreciable difference through the hose and then down to the power nozzle. So it would translate to probably a 1/10 or 2 difference of a CFM. So let's see, I'm at 119.5 volts. That's unloaded. Let's crank her up. It's on max. And see the voltage drop? Now, if I was at my lab, it'd be about 121 volts. So there definitely will be a little bit of a CFM boost. So I've got everything sealed up. And let's see what happens. This is what matters to me anyway. I want to know what kind of CFM you've got at the power nozzle with all the bags and filters in. Oh, and it does help if I go and pick the right unit. There we go. Feet per minute, preferable. All right, let's see what we got. Alright, we're looking at about, close to 2,500. Can we get a little more, or is this going to be it? Yes. Woo! Alright, there we go. Alright, without boring you too much, think that's going to be it. 2539. 2539. We're at 66 nozzle CFM. 66. And notice I have that set on 1, so everything's as flat as it can possibly go. It's the best seal I can actually get. So 66 CFM from this guy. We can listen once again to the dry bearing rundown. I can't wait to go and tackle those bearings. Okay, so 66 from this guy with this, I think it's an SEB 228. Machine's about 6 years old. Everything's as clean and as tight as it's going to be. So, what'd you think? Alright, my stint here in Florida is over, and that means the usefulness of this airflow box is also over. So away it goes. So $1.20, I don't know, Walmart $1.24 I think box, now flattened.